and welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend.
I'm Connie. I am a curious friend to the universe who learns so much from my co-host.
Oh, hi. I am Dr. Moiya McTier. I'm an astrophysicist and a folklorist who loves to share what I know and introduce other people to my friend, the universe.
It's so great. It's been so great. So to wrap up Moiya's birthday month, we wanted to do a rapid fire episode of Moiya's favorite space facts, specifically 31 for her birthday.
Yay.
So I'm excited to get into
first,
this. Just so you know, I'm going to let her fly.
Let me nerd out.
Yeah, I'm going to let you nerd out, and we'll make some notes where we may need to deep dive, or where there might be an episode previous that you can deep dive at some point.
Yes.
Yeah, we'll figure that out.
Excellent. But before we get into my favorite space facts, Bestie, do you have a favorite space fact?
I think currently it is the fact that the moon always faces the same side of the Earth. And we learned recently about parallax and how it's not just 50%, but like a 60%. But I think it's so cool that the moon... Is that the wrong...
Parallax.
Is that the wrong phrase? It is the wrong phrase.
Libration.
Libration.
But we did also learn about parallax.
We did also learn about parallax. So, you know, I learned, and then I just mixed them up. But we learned about libration and how it's not quite 50%, but like a 60% of the moon that we actually see because it shifts. But like the fact that it's like always facing the same direction because of just like, tidal locking?
It's always facing...
We always see the same side.
Yes.
That's what I really mean.
Yeah. It does face different directions over.
But is there something that we talked about earlier that is tidally locked to its planet?
Yes. That's one of my favorite facts.
Okay, great. So I like that that's a thing in the universe. It's like such a specific, like the things have to happen in such a specific manner for that to occur. And it happens more than once. That's very cool.
That's fun.
Yeah. Okay. And on your marks, get ready. And number one.
In no particular order, my first favorite fact about space is that you can tell how and when a star will evolve to its next stages based on its initial mass. So we know that a really high mass star is going to only fuse hydrogen in its core for about 10 million years. And then they'll explode as supernovae. And we know that the really low mass stars are going to take trillions of years to fuse their hydrogen, or at least a trillion years to fuse their hydrogen. And we don't really know what's going to happen next. But perhaps, like, probably just become like a chunk of rock, a white dwarf thing. Yeah.
Math.
My next favorite fact about space is that we cannot see with our unaided eyes any of the most common type of star. According to the initial mass function, the saltpeter initial mass function, which was developed by an astronomer named Saltpeter, I was friends with his grandson in college. And it was really funny when I was like super struggling to grasp this concept in class, and I would go to Caleb and I'd be like, Caleb, what did your grandpa say?
Like, what did he mean?
What did he mean? But the initial mass function is just the idea that most of the stars that form are going to be really low mass stars. About 75% of the stars are like M dwarf stars, about 10% the mass of the sun. And then very few, like 5%, are going to be super high mass stars, like the O types and B types. And those most common types, the low mass stars, they aren't bright enough for us to see in the night sky.
Right.
All of the stars we see are higher mass.
Right. That does make sense when it's like, yeah, of course, the brightest things are the things that we can see better. But that's not. And then we see so many stars in the sky, and it's like, there are so many more. Wow.
So what we see is not representative, which is just a really good lesson in perspective, folks, because what you see is not all that's there.
Not at all. Wow.
Life
That's
lessons too. My third favorite fact is that Uranus rolls around the solar system on her side with a 98-degree tilt. She's so sleepy. I love her so much.
That is so funny of a fact. And it's just like, wow. And then you think about it rotating. And then it's funny because, like, of course, here on Earth, we can't really feel the rotation in the way of like in the speed that it is. But if you get too, like literal about it and you're like, okay, well, if we're on Earth and it's spinning this way, like, fine, like you get used to that perspective and scale. But then if you try to flip that on its side, literally, it's like, for some reason, it's a little like, oh.
You feel a difference.
Yeah.
You definitely feel a difference because Uranus has the most extreme seasons over the course of its year because of its tilt.
Oh, yeah, we might have to get into that more.
Yeah. Well, there's a whole Uranus episode
great.
that people can go listen to.
Let's do that.
My fourth favorite space fact is that the boundary between the day and night side of a tidally locked planet, so a planet that, like the moon, is always facing its star, that line that separates them is called the Terminator. That just tickles me. I don't actually know if I've seen the Terminator movies.
I have recently, but only the second one. I was told the first one, that's that one.
Oh,
I think it's Terminator 2 that is the most the really popular one. Okay. But we may have watched Terminator 1 after. But we watched Terminator 2 first because that's the iconic one.
Mm-hmm. Oh, okay. All right, good. Yeah. Well, that's also the name of the line between the day and night side of a tidally locked planet.
Okay.
Number 5. Earth is closer to the sun during the Northern Hemisphere's winter than we are during the Northern Hemisphere's summer.
Is this your favorite fact, or is this just the fact that you want the most people to finally understand?
Both.
Okay.
Both of them. Like, I need more people to know this, and also the fact that I get to tell so many people this brings me the ultimate joy. I love it. Because it's so demonstrative. And that difference between our closest approach, which we call perihelion, and our farthest approach, which we call apohelion, that difference is 5 million miles.
Right.
It's a big difference. Not in space, but for us.
Because it's about the tilt.
Yeah, exactly. My sixth favorite space fact is that scientists thought the cosmic microwave background signal was bird poop for a while. So the scientists at a physics lab went out and cleaned a telescope outside dish of bird poop. And then went back to take their measurements and were like, we're still seeing this signal. It must be the Big Bang.
Okay, Bob, can you just get out there and just scrub the thing? I don't know. It must be something.
Wait, one of them was named Robert. One of them was actually a Bob.
There's always a Bob. There's always a Robert somewhere. Can you just go out and just, scrape the bird poop off the thing for me, please? Thank you. Thank you. I think it's messing up the number somehow.
Number 7. Edwin Hubble called elliptical galaxies early types and spiral galaxies late types, even though we now know that most elliptical galaxies are spirals that have collided with each other. And so the elliptical galaxies are actually later types and the spirals are early types. Edwin Hubble didn't have any idea how these galaxies evolved, but he did really like classification schemes. And so he developed the Hubble tuning fork, where he put the elliptical galaxies on the left and the two branches of spiral galaxies on the right. And because the ellipticals are on the left, he called them early types.
Bro. Come on, man. Even if you're not trying to get into how they evolve and everything, you wouldn't think that might inform the reasoning of what people think it is. Just use left and right.
They do have a different color. The elliptical galaxies are redder, so they tend to have older stars because the stars are older. They are from older galaxies that have merged, but that new galaxy is new. Yeah, so late types. Well, I mean early types because those stars formed early.
Oh, but I thought it was about the galaxy itself.
It is about the galaxy itself. Yeah, so it's just all very confusing nomenclature.
Yeah, it's all very confusing.
This is why nomenclature is important.
It's important.
Why next week we're doing a whole episode on nomenclature, friends. So just stay tuned. My 8th favorite space fact is that spiral galaxies maintain their shape through rotation, through the orderly orbits of their stars in the disk on circular patterns, whereas elliptical galaxies tend to maintain their blobby cloud-like shape through chaotic pressure. Because the stars aren't moving on neat circular orbits, they're moving in any type of shape. That pressure, that motion produces structure. So sometimes you can create structure through chaos, which
absolutely.
is what I feel like I do in my career.
Yes, definitely. Definitely. That is fascinating because like spiral, it makes sense. Like spiral galaxies are kind of just like when you think about centripetal force and like how things just kind of move. If things in a circle kind of tend to keep going in like a, that shape, versus the elliptical, which is honestly, it just sounds as chaotic as it sounds.
Yeah. Okay, number 9. My 9th favorite space fact is that no object can move faster than the speed of light, but the edge of the universe is receding away from us faster than the speed of light. It's just that those galaxies are not themselves moving. Yeah. Mm-hmm. 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 Yeah.
No, I don't know. I don't get it.
Okay. Oh, I thought you were just denying it. Perhaps a future episode, because I do want to, there's some weird edge of the universe stuff that we can talk about.
Yeah.
But
because I feel like I'm pulling it, this is stretching apart into a black hole or something when you say that. So I'm going to need a breakdown to that. Right?
Okay. Yeah, that's a longer episode then. But it is one of my favorite facts. This might get you to have the same reaction. My 10th favorite space fact is that photons don't experience time because as an object moves faster, according to relativity, the rate of time passing for that object slows down. And if you take that to the extreme, if you're going as fast as you physically can go, which photons are doing, they're going at the speed of light, then the time passage rate drops to the other extreme. It drops to 0. So photons do not experience time.
Somehow that's it's an element of supporting evidence for fact 9. Like it feels like those are going to be related. But that's all I got. So, okay.
I know there's another fact in here that is very related, but I can't remember which one it is. It's coming up somewhere. My 11th favorite space fact is that gold is produced, and other heavier elements. It was produced in cataclysmic events like neutron star mergers. Like the jewelry that you wear every day, that stuff was produced when the densest objects in the universe collided with each other billions of years ago.
Okay, now, so gold isn't just on Earth, right? It's
Correct.
on other planets.
Yes.
But we haven't figured out how to get it.
Now you're talking about space mining.
Right. And when I've heard that phrase, I really didn't think about what it meant. Like I've kind of just let it sit in my head. It's like, okay, that's a thing. And, it doesn't feel like a great thing based on, sci-fi TV and shows and stuff. But now that I'm really getting to understand this, I'm like, yeah.
Yeah. And also a bunch of asteroids with their precious metals.
Right.
Yeah. And precious metals near the surface too, and not churned throughout because they don't have their own geological systems.
So are we do we need to have an episode about space mining and the implications of that?
I know I have talked about it on some episodes in the past. I don't think I've done a whole episode just about it. So maybe. Yeah, if we want to be sad.
Oh.
Yeah.
What formatting do I put for being sad? Underline is all that's left.
You're right. Underline is we should do this episode, but we won't do it.
It will be sad. It will be sad.
That has been the Challenger mission since the beginning of the pod.
Oh.
Yeah.
Oh.
Yeah.
Well, listeners, you let us know if you want us to discuss the sad stuff. And, we'll think about it.
You're right. We'll do it for you. We'll do it for you all. Fact number 12, astronomy spacecraft almost always last longer than we planned them to last because we're really good at fixing them or changing the mission. So the Kepler spacecraft is my favorite space mission, and it was launched in 2009. By 2014, it had broken in a way that it couldn't redirect itself to point at the same place in the sky. So then NASA figured out a way to let it just roll and stare at different parts of the sky as it orbited in the solar system. And I like that we're resourceful.
Yeah, that's great. More major industries could use that.
Mm-hmm. My 13th favorite space fact is that about 85% of stars are born in pairs or more.
Oh, a little family.
Yeah, like so many twins, so many triplets. We've seen, what is it, septuplets.
The Octomom, but in space. The Octomoons. I mean, the Octomoons are the grandchildren of the...
Yes, of the stars.
Yeah. You know, in a
You're
way.
right, they're the grandchildren.
Mm-hmm. Yeah, because there's a star, then there's the planets, and then there's the moons.
You're so right, bestie. Because space is fractal. That should be another one of my favorite facts. Space is fractal. You see these same structures on multiple scales. You see galaxy clusters that come together through gravity. You see clusters within galaxies. You see spiral galaxies that have spiraling solar systems within them. We're all made up of atoms that have these like spiraling electron clouds. So it's so beautiful.
Wow.
That was fact 13 and a half.
Yeah.
Fact 14, the universe isn't old enough yet for any low-mass M star to have evolved to the next stage of its life after hydrogen fusion.
And will it in any of our lifetimes?
In any of our lifetimes?
Of
no.
the Earth's lifetimes?
No.
That's crazy.
Yeah. Our sun will die before any of these M dwarf stars die. And die isn't even the right word to use. It's just like fusing the hydrogen in its core.
But it's very brain wrinkling of just like, it's like, yeah, I know how, the kind of the hows of how we can tell. But it's like we weren't here when it started. And we won't be here when it ended, like as a planet. Like I know how we know, but like, how do we know?
So the low mass stars, they're really thorough. The low mass stars are really thorough when it comes to their hydrogen fusion. They are good at cycling all of their material from the outside to the center. And in that way, they can actually turn all of their hydrogen into helium. Other more massive stars, they're not as good at that transport mechanism. So they don't get to fuse all of their hydrogen. So they finish faster. The high mass stars finish faster, but the low mass stars are more satisfied, ultimately.
And I love that for them.
Yeah, good for them. I don't relatable. Hey everyone, it's me. All that talk of gooey convective layers got both of us craving a chocolate lava cake, so Connie's gonna go get us some from the food hall, and I'm gonna take this moment to share some messages with you. The first message is, of course, a big thank you to all of the patrons who support us financially on Patreon. We couldn't make this show without you. We're an independent podcast, so we truly appreciate your support. And we want to give a special shout out to our Sun-like stars, Scott Reynolds, Tom T., Nicole Bartlett, Ashley Shambo, Mark Mahoney, and Bruce Sedloff. Thank you, thank you, thank you, my golden friends. If you want to support this indie podcast on Patreon, you can hear your name on the show, make it onto my Patreon star chart, and get research notes for most episodes for $5 a month at patreon.com/palebluepod. You can also make a one-time donation and become a supernova in the Pale Blue Pod sky at the PayPal link in the show's description if a monthly donation is not something you're interested in right now. And if you can't support the show financially, we understand. The best way to help Pale Blue Pod grow is to get more people listening to it. So if you take a link to this episode and send it to someone who just wants to have some space facts in their back pocket to pull out at a dinner party, please send it their way. And I would appreciate that. So would Connie. Thank you in advance. My next message is a podcast recommendation. It's called Spirits. It's one of my personal favorite podcasts. It's a history and comedy podcast focused on everything folklore, mythology, and the occult, told through the lens of feminism, queerness, and modern adulthood. Every week, mythology buff Julia and her childhood best friend Amanda get together to learn about a different mythology story from around the world over drinks. That's everything from the origins of major franchises like Lord of the Rings and Wonder Woman and Pokemon, these stories that we all love that draw from real folklore, to modern urban legends that their listeners send in, to like a roundup of werewolf stories from around the world. I am excited to listen to their Appalachian folklore episode with Chuck Cora. As a Pennsylvanian from the woods of Penn's Woods, I definitely want to hear more about the folklore and see if it matches what I heard growing up as a kid. And that's the beauty of spirits. Everyone grows up with folklore around us, and it's nice to hear it presented in this like really educated but compassionate and welcoming way. You can start listening to any of their 450 plus episodes that they've released over the last 9 years at spiritspodcast.com or by searching for Spirits wherever you download your podcasts. The link is down in the episode description, so check out Spirits wherever you get your podcasts. All right, Connie is back. The dining staff here at the Podiversity actually work with the geology department to make the cakes look like actual little volcanoes. They're such a treat. So we're going to eat these while they're still hot and then get back to discussing my favorite space facts. My 15th favorite space fact is that southern hemisphere cultures are more likely to have dark constellations, in addition to the bright asterisms, because our solar system sits ever so slightly above the midplane of the Milky Way galaxy. So the southern hemisphere is actually looking down at more of the plane of the galaxy, and they can see those dusty voids down there, which we can't. So that's why you have a better view of the Milky Way at the equator and then down in the southern hemisphere.
One day this podcast is going to fundraise a trip so that we can go to somewhere in the southern hemisphere so that I can see this, because all I want is to be able to see what I've sort of seen in pictures and Moiya has described of just like going down and like, yes, there are the big stars, but there are so many like dark spots in the sky. And then the local constellations that are based on, or maybe asterisms or whatever it is called, that is based on the negative space of the thing, as opposed to necessarily the big bright spots like in the northern hemisphere. And I need to experience that from like a field in South Africa where I can just like look up at the large swath of sky. And I've been on a Jeep. And you get out there and I got hot cocoa in a thermos. And that would be so lovely.
Yeah. Yeah. Let's do it, bestie.
One day.
And then, like, they could use those dark constellations in the same way that we do in the northern hemisphere use our bright constellations. Like the ancient Egyptians would use the star Sirius when it was coming above the horizon to know that the Nile River was about to flood. So they would have a fertile field to plant their crops. And the indigenous Australians in the southern hemisphere were looking for the dark emu constellation that would fly across the sky at the same time that the emus on land were laying their eggs. So they knew that they could go and have that valuable source of nutrition. And just like the way that ancient cultures were able to look up at the sky and use it for these practical purposes. Just
it's so cool. It's so cool. It's so cool.
My 16th favorite space fact is that if our sun became a black hole tomorrow, our planet's orbit would stay exactly the same. All of the orbits in the solar system would stay exactly the same. However, because there wouldn't be heat coming from the sun anymore, we would all freeze to death in a few weeks.
Bestie, I really like your restraint in putting this at number 16.
Thanks. I didn't have any other destruction and death ones.
I'm very proud of you. Thanks.
And this one was half hopeful.
And there wouldn't be light, correct?
No more light except for starlight, which is basically nothing. We wouldn't even have the light of the moon because that's all just reflected sunlight. So we wouldn't see the moon anymore.
Like at all? Could we see? We couldn't see on the planet, like each other.
Well, we would have our own artificial lights.
True. Someone might be trying to write this book or, screenplay of like, what if the sun went out tomorrow?
Why do they talk like that?
I don't
know. Yeah. But a lot of people think that we would get pulled into the black hole, and that's just not what would happen. We would stay where we are. We would just freeze. My 17th favorite space fact, and I think you will also be impressed that this is as low in the list as... And again, this is in no particular order. In no particular order, as they say on Love Island. Number 17, a woman named Vanna Bonta in 2006 invented a suit called the Two Suit, which was specifically designed for people to have sex in microgravity environments because it velcros you together strategically so that when you thrust, you don't bounce apart.
There are so many questions, involved here. So the two suit was giving one big suit that was like all connected, but it could fit two people in it. And now it sounds like it's actually everyone in their different suits, but like with Velcros. Is the Velcro just help?
It's quite hard to find documentation on the team suit, but I think you are in your individual suits so that you can uncouple and do other things besides boink. But it has ways that you can attach yourselves to each other. So that, yeah, you get that part.
Yeah.
You understand why you would want that.
Yeah.
Because, Newton's law says that for every action, there's an equal and opposite reaction. And there are just a lot of actions in that particular activity.
Yeah.
Where you don't particularly want an equal and opposite reaction.
No, especially not in microgravity, not at different, no.
Yeah. And yet, okay, so we've invented that. And yet the official stance for NASA and any official stance from all of these space bodies has been that no one has had sex in space.
It's like, I guess it does seem very tediously difficult that, why would you try? Would you have the energy to really want to try? But also, I don't know that anybody could say no one has it.
Who are you talking to?
You're so right. I was really just thinking about, I would be too lazy to try to figure that out. But not everyone is like me. So but also I don't think you could say that no one has. I absolutely believe someone has. I just am I could see that it not being as many as maybe one would hope, because it's that just sounds like a tedious, your free closed environment where you get any privacy. It just sounds like there would be a really difficult time.
Yeah. You're right. It doesn't sound fun at all. Number 18, my 18th favorite space fact. And this is something that you alluded to earlier. Charon and Pluto are kissing. They are doubly tidally locked.
Right.
So there's some action in space. And
I think there would be.
Yeah.
And I think they probably are just really worried about someone having a baby in space.
Yeah.
Because then it's what are the what citizen, there's just all these bureaucratic questions that people start to ask. It's don't even go there.
If someone conceived in space, they're not giving birth in space.
You're right. But
and if someone is conceived on Earth, they're not giving birth in space. You're not putting an already very pregnant woman on us.
True.
They can't even get on planes.
I wouldn't be surprised. You're so right. What if she was pregnant at a certain stage and then she was just already pregnant?
I do think a pregnant woman has gone into space before, but at an early stage.
Yeah, the new Fantastic Four movie, Sue Storm has her baby in space as they're escaping a black hole and everything. So it came to mind. I was dang, he's a citizen of HR Black Hole 32. I don't know. From Earth, whatever Earth they were in, 836.
Oh, no. No, there has not been a pregnant person in space. I was just thinking of the very excited headline that I saw where people were like, oh, the first mother went into space.
Oh.
I'm yes, good for her,
yes.
but
yeah. How many of them have been fathers? Come on.
Come on. Charon and Pluto, they are doubly tidally locked.
So cute.
So cute, because their mass ratio is 1 to 2. So it is energetically favorable for and possible for them to actually exchange comparable amounts of gravitational energy. And so we think that Charon was probably a different small body that kind of grazed across Pluto. It almost collided, but not in a way to destroy either of them. Very gentle. And then because it was so close, Pluto's gravity, which is twice as much, it just captured Charon. And so they call that technique the kiss and capture technique.
That's only made it a spy technique. Right?
Kiss and capture. Yeah, because they could have just called it U-hauling.
Yeah. Exactly.
That's what I'm actually going to call U-hauling from now on. I'm calling it the kiss and capture technique.
Kiss and capture.
My 19th favorite space fact is that a solar day on Mercury, meaning sunrise to sunrise, is twice the length of a year on Mercury, the time it takes to go around the sun once. That is 176 days versus 88 days. And that's because of Mercury's very slow rotation, which is something like 55 days. It's in a 3-2 resonance with its orbital period. So for every 3 times the planet spins, it goes around the sun twice. And so like in the way that that works out, the sun rises and then sets a little bit and then rises again and then has another setting before it completely rises. So like that full cycle, you have to go around the sun multiple times to see that full cycle. It's very weird. Yeah.
Yeah.
So like it's hard to define a day on Mercury. Whereas on Venus, it's easy to define a day. It's 243 Earth days. That's its length. But that very simple day is just longer than the length of its year, which is 225 days. So Venus just rotates more slowly than it orbits, than it revolves.
Right. Okay. Mercury's like, it's too hot to go too fast here. Okay.
Yeah. Yeah. Let's spin slowly. And so is Venus. It's like, let's spin really slowly. My 20th favorite space fact is that sun-like stars have an average of 2.5 planets to them, like a nuclear family with a white picket fence from the 50s. I love it.
You know, when a mommy planet and a daddy planet really love each other, they might collide and break off a moon.
Yes, exactly. And then my 21st favorite space fact is related. It's actually just like the title from this paper by Leslie Rogers in 2015, and it's one of my favorite paper titles ever. It's most planets larger than 1.6 Earth radii aren't rocky. Okay, so if it's a certain times bigger than the Earth, it's not a rocky planet, but it could be like a gas one. Yes.
Is the ice planets?
That's a separate category.
Okay, and they don't have features?
I think they do have some features, but not like mountains and stuff that we do. Like they'll have ice cracks, but we're not trying to name some ice cracks.
Yeah.
Well, they have mountains too. Yeah.
Gotcha. Okay.
And so it's not based on mass, which is interesting, but based on size, because as you gain more mass, the gravity, your like own self-gravity will condense you to make you a smaller physical size. So we go based on the size, because once you are that physically big, it is like no matter how massive you are, it's hard to condense more. Right. So beyond that, you're probably gaseous or icy. My 22nd favorite space fact is that there was a total solar eclipse in May of 585 BCE that ended a 5-year war. Solar eclipses were seen as bad omens, and there was this war being fought between the Lydians, who were from modern-day Turkey, and the Medes, who were from modern-day Iran. And according to Herodotus, they fought on the battlefield. This eclipse had been predicted by Thales earlier, and when it passed over them, they thought that it was like a god being angry, so they stopped fighting, and then afterwards they brokered a peace with a marriage between their people.
Oh, yes, it was like we gotta appease the moon gods. That's we was wild, and they said now it's time to be over.
Yes.
Okay, great. Noted.
Space fact number 23. Serpens is the only non-contiguous constellation. It's split into the front part of the snake and the back part of the snake, and it's split by Ophiuchus, the snake wrangler.
Okay, what do you mean by non-contiguous constellation?
Just like the contiguous United States is all the states that are touching each other. All of the constellations are like a solid chunk, except for Serpens, which is 2 separate chunks that don't touch each other.
Oh.
And yet they are the same constellation. It's like if there was a whole river that split Pennsylvania in half, but it's still both Pennsylvania.
Because of how we made the borders.
Yeah.
Okay.
So like when the IAU was deciding the constellations, like they decided that for some reason.
Right. Yeah. That's what I'm like, but we just made that up. Like, it's not like it's
because it's based on the Almagest. It's based on ancient Greek constellations. So.
Yeah. So it's like it must have already existed, but it's kind of like some of our states are just like oddly cut because of random like political and whatever borders, and it's like it didn't have to be that way. You could fix it, and you could just change it if you wanted to, but it's fine. It's fine. Doesn't hurt.
24 is very fun. Dung beetles follow the light of the Milky Way to navigate. And we know this because when we put tiny little hats on them, they get lost. They are looking up, and if we just like put them in a room with random lights, they also are lost. Like they are following the light of the Milky Way. They're little dung beetles as they're rolling their poop.
But what does following the Milky Way mean?
They use it as like a compass, so they will orient themselves. So dung beetles, they roll up their poop, and then they use their back legs to roll it, and they put their front legs on the ground like a wheelbarrow, and then they roll backwards. And before they start moving, they will position themselves so that they are either like in line with the Milky Way or like they're orienting themselves using the Milky Way to figure out how to get back to their home.
Huh. Dung beetles, huh? Because I guess the light of the Milky Way part is what's tripping me out, because I'm like, is not all of the stars and constellations the light of the Milky Way?
Correct. The path, like the Milky Way path, not just the Milky Way galaxy. Well, it's like with the dark constellations. They are specifically in the southern hemisphere seeing the cloudy, dusty voids that is in the path of the Milky Way, like the bright stream that you see if you Google a picture of like astrophotography of the Milky Way, you see that single stream. That's why they call it the Milky Way or the Silver Path, because it looks like a river of light. And in the southern hemisphere, you can see spots in that river of light, not elsewhere. It doesn't take up the full sky. There are stars elsewhere, but they aren't disk stars in the path of the Milky Way.
Okay.
Yeah.
I'm gonna go get a visual of that one.
Yeah, it does help to have like seen it in person to get like the striking difference. You will get that, bestie.
Yeah, we're getting there.
Yeah.
We gotta get there.
Fact number 25. The black hole in the center of our galaxy is named Sagittarius A star. It's called that because it's in the Sagittarius constellation, and it's in like there were multiple objects in the Sagittarius constellation. This was the central one, so it's called A. We didn't know what it was until 1982, or even later when we realized like it was a black hole. But I think we realized that it had a lot of X-ray emission in 1982, and that was very exciting to physicists. So they called like the black hole object specifically, which they didn't know was a black hole yet, Sagittarius A star. And that's because in physics, atomic states that are excited when the electrons are at a higher energy level, they denote that with a little asterisk. And the two scientists who like found this exciting emission, they just thought it was so exciting that they put a little asterisk for its official name.
They're like, no, but this is really cool. So like, it's really special. We can't tell why, but it's just really special. So there's going to be a star because we might have to come back to this. We're going to want to remember this one. You sure are.
It's just so exciting. Space fact number 26. The International Space Station has been continuously occupied since November 2nd, 2000. That's over 25 years. I just think that's really cool. It's like a very long running science experiment.
Yeah.
And international, like, interpolitical experiment as well.
There should be a sitcom, like an office sitcom of the ISS. That would be a great one.
Seth MacFarlane should contact me about that. That would be really fun. Call him up.
Yeah.
Space fact number 27. The Milky Way and Andromeda galaxies, I think many of us know that they are going to collide in about 5 billion years. However, they are already kind of touching because both of these galaxies have huge halos of dark matter that surround them that extend out to almost like 2 million light years. And the galaxies themselves are 2.5 million light years away from each other. So our dark matter halos are already overlapping.
My halo!
Fact number 28, Earth gains about 40,000 metric tons. That's not just regular American tons, that's metric tons. So this is about 88 million pounds every year through meteorites and cosmic dust and other things falling onto the Earth, even though Earth is losing material at the top of its atmosphere through atmospheric evaporation. Like the little hydrogen molecules and other things are being excited away from our atmosphere. And so we're losing weight, but we're gaining enough weight that we are net gaining 88 million pounds of Earth every year.
And this is the thing that's always been happening and we just discovered it, or is it just... Yeah. Okay.
We've known about it for a while, but yeah.
As opposed to like something has changed.
I don't think there's been a significant change, no.
Okay. Yeah. Interesting.
Yeah. Fact number 29, Ganymede, the gay Galilean moon, is the only moon in the solar system to have its own magnetic field intrinsically, even though Venus, Mars, and Pluto all have such insignificant intrinsic magnetic fields that we basically it's weak. Like this moon has a stronger magnetic field than these 3 planets.
Oh, wow.
Yeah, it's the only moon in the solar system to have its own.
Why is it the gay one?
Because Ganymede was a boy. And this is back before 2004. We'll talk about this in the nomenclature episode. But this was back when all of Jupiter's moons were named after lovers of Zeus.
Right.
Because Ganymede was this beautiful mortal boy that Zeus fell in love with and whisked away to be his cupbearer up in Olympus.
Right. Okay.
But we all know what cupbearer means.
Yeah, we do. We really do.
Fact number 30, and this goes back to photons not experiencing time. Okay, so photons don't experience time, but we do. We can measure how long it's taken those photons to travel. And it takes photons 8 minutes to travel from the surface of the sun to the surface of the Earth. However, those same photons, there's a philosophical question here, but basically those same photons will take 10,000 years up to 1,000,000 years to travel from the center of the sun to the sun's surface.
Right. So it's
called a random walk of photons.
Yeah, I think in our episode about it, there was something about they just get lost, bouncing between or against other things. And so it's just what's going on? And then it's out and it's just
yeah. Yes.
That's funny. That's funny.
Yes. Fact number 31. My favorite, this is my favorite space fact. And it's, a fact that I tell you all every single week because I believe it so much. And it's that we are space. All of the material in our body was formed in the cores of supermassive stars that then exploded as supernovae. And that explosion created a shockwave that carried that material out into the interstellar medium, which got swept up into the next generation of more metal-rich stars, which then collapsed into this gas cloud with a protoplanetary disk, and we formed by the tiny, slow accretion of pebbles into planetesimals, into planets. And we're on that chunk of rock, and we don't know when life started, but it did with all the material that was here in this same gas cloud from ancient stars. And we're wearing jewelry that was formed in even bigger, more massive, more accomplished stars. And everything is connected, and we are space. And there's no reason for us to fear this thing that is not just eternal and has always been there and will always be there for our purposes, but it's we are of it. I like that.
That was beautiful, Bestie.
Thanks.
Thank you for sharing all of your space facts and for sharing all of your space knowledge with us. Happy birthday, Bestie. I hope you've enjoyed your birthday month. And with that, everyone, remember your space.
Yeah.
Pale Blue Pod is hosted by Dr. Moiya McTier and Connie Gibbs. Moiya created the show with the funny and talented Karine Caputo with help from the Multitude Productions team.
Our theme music is by Evan Johnston, our cover art by Shay McMullen, and our audio editing is handled by the superlative Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Instagram or check out our website, palebluepod.com.
I, Moiya, am Go Astro Mo on all socials.
And I'm @ConStar24 on Instagram.
If you want to support our show, join our community at patreon.com/palebluepod or send this episode to your family and friends group chats.
We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
Thanks for listening to Pale Blue Pod. We'll be back next week.